The next part is we will be examining the stress path followed in each of the 4 tests we just have discussed. So we will present a schematic uh, diagram of the specimen showing yung boundary condition and applied stresses, and of course yung diagram showing the Morse circle for the test, in which we have to plot the failure envelope and determine the shear strength parameters na yung phi and C. So we have here the first, yung UC test. So in UC test, ito yung magiging diagram natin. So in UC test, a stress vertical is applied doon sa ating soil. So, ito yung schematic diagram ng ating specimen, and ito yung Morse circle natin. So, in UC test, a vertical sigma 1 is applied to the soil without any lateral confining pressure. That is, yung sigma 3 natin is equal to 0. So, therefore, yung magiging Morse circle natin, since yung sigma natin 0, andito sa ating origin yung sigma 3 natin. So, yung Morse circle for this test are all tangent to the axis, and then if the vertical stresses, yung in-apply nating sigma 1, increase. So, nag-i-increase siya until yung soil natin fails. So, at failure, meron tayong tinatawag na sigma 1. So, at failure, the maximum principal axis is denoted by this symbol sigma 1, or tinatawag nating QU. So, this is a total stress since we have no measures of the pore pressure and cannot determine, since this is a special type ng ating triaxial. And so, the effective stresses in the soil, yung peak stress natin, so yung peak natin at failure. So, yan yung magiging peak natin at failure. So, ganyan yung value natin. So, the peak shear stress at failure is measure of the undrained shear strength. So, ito yung undrained shear strength parameter natin na CU. So, there is no failure envelope for the UC test since we have only one Morse circle in this test. So, ganito yung magiging Morse circle natin if we have unconfined compression test. Yung phi natin is 0, yung sigma 3 natin is 0. Here, the unconsolidated undrained triaxial test, or yung tinatawag nating UU test. So, the UU test is another total stress test. So, like the UC test, we do not measure pore pressure and we do not compute the effective stresses. So, the purpose of our UU test, yung UU test natin is to determine yung undrained shear strength natin. So, yung undrained, sabi niya, so the drainage valve is closed throughout yung ating UU test. So, we have here a diagram showing yung Morse circle natin sa UU test. So, initially, there is no stress on the specimen. And yung Morse circle natin appears as a point at here, dito sa ating origin of our Morse column diagram. So, as we apply yung cell pressure doon sa ating specimen during the consolidation phase, yung Morse circle natin remains at point sigma 1. So, meron tayong point. So, at point sigma 1 and sigma 3 that are both equal. So, ito yung point natin. So, wag niyo munang pansinin yung mga drawing natin. So first, yung initial stress natin is 0 since no stress on the specimen. And then, as we applied cell pressure, magkakaroon na tayo ng sigma 3, yung ating confining pressure. So, however, yung Morse circle natin move to the right along the sigma axis as the cell pressure increases. So, nag-increase siya. So, yan, nag-increase yung ating stresses. So, once cell phase is completed, yung shear phase natin starts by increasing yung ating vertical stress that is applied doon sa ating specimen. So, as we continue to increase the vertical stress until the specimen fails, once again, meron tayong principal stress at failure, yung ating sigma 1. And the soil has an undrained shear strength, Cu. So, meron tayong Cu dito sa ating shear. Ito yung shear natin, value ng shear natin. Ito yung value ng ating normal stress. So, we have here again the sigma 1. So, because the drainage valve was closed during yung consolidation phase natin, no consolidation occurred and the soil did not gain any strength during this phase. Therefore, yung undrained shear stress natin under a confining stress is no greater than the undrained strength natin measured by an unconfined compression test on the same soil. So, on the same soil, meron tayong isang more circle that is no greater than yung sa ating undrained. So, meron tayong isang more circle dito. Measured by the unconfined compression test. Similarly, if we conduct another identical soil specimen, so we will conduct another test. So another test specimen na ito on the identical soil specimen. But, i-raise natin yung value ng 0. So, ito yung value natin. I-raise natin yung value natin ng sigma 3, no, not 0. I-raise natin yung value natin ng sigma 3 during consolidation to this point, yung itong point, the soil still would not gain any strength because walang consolidation na inaalaw during yung UU test. So, this test would have the same undrained strength as the two previous test natin if we plot yung total stress failure envelope natin. So, for this test, we will be having a slope of 0 kasi pare-parehas sila, wala tayong nag-gain strength. So, pare-parehas magiging horizontal yung ating slope failure, yung failure natin, failure envelope natin. And yung ating shear stress will now intersect at CU. So, ito yung pangalawang test natin. Ito yung tau natin that represent yung shear stress natin. Shear stress, meron din tayong shear stress dito. So, they all intersect at value of CU doon sa ating failure plane. So, yung failure envelope natin na phi, since horizontal ito, 0 yung ating phi. And then, yung ating CU, meron tayong CU is equivalent to yung ating shear stress dito sa ating soil specimen. So, this is known as the phi equal 0 condition. Tapos, yung saturated clay natin loaded in undrained condition fails under phi is equal to 0. So, dito mag-fail yung conditions natin dito sa UU test. Next, we have here the consolidated drain test or yung tinatawag nating CD test. So, in this test, the drainage valve remains open during both the consolidation and the shear phase, and any excess pore pressure that might be generated are allowed to dissipate, so there is no excess pore pressure in our CD test. So, yung CD test natin is an effective stress and the total stress are equal. So, this is then an effective stress test, yung ating CD test. Effective stress test yung CD test natin. So, we have here the diagram of the Mohr circles in the CD test. So, ang example natin is a normally consolidated clay. Kasi yung cohesion natin is 0. Pag hindi normally consolidated clay yung clay natin, yung cohesion natin is not 0. So, meron tayong value ng cohesion. Pag hindi normally consolidated yung ating clay. So, yan. So, meron tayong value nung ating cohesion pag hindi normally consolidated. Pag overly consolidated, meron tayong value na cohesion dito sa ating y-axis. So, during the consolidation of the Mohr circles, again, point at the origin, so yung point natin dito sa origin at to point here at our consolidation stress, yung sigma 3 natin dito, yan, meron tayong sigma 3 dyan. So, in this case, yung sigma 3 natin is the effective consolidation denoted by sigma 3 prime. So, effective. Because there are no pore pressure and the soil will consolidate and increase in the strength. So, if the soil consolidated and increase in strength, yung ating sigma 1 is then increase until the soil fails. So, meron tayong sigma 1 dito. So, yung test natin dito sa CD test, yung shearing is done slowly, that no pore pressure are generated. Therefore, yung major principal axis natin at failure is also called the effective stress. So, equal yung sigma 1 natin, that is the stress, yung total stress natin, that is equal to the sigma 1 prime. Yung prime natin denotes na yung ating soil is yung ating stress is in effective condition. So, if we test another specimen, but consolidated to a higher confining stress of soil, so meron na tayong higher value ng sigma 3 compared doon sa ating first specimen. The soil will now gain strength during consolidation process, and when sheared, it will have a larger, more circle as failure, as shown here. So magkakaroon na tayo ng larger failure ng more circle. Yan. So larger. So meron tayong for the second test, meron tayong sigma 3 and sigma 1. So likewise, if we run another test, kung meron kayong third test at yet higher confining stress, again the soil will consolidate and have an even larger, more circles at failure. So looking at this figure, using the two failure circle shown dito, yung two failure circle natin, we can plot the failure envelope as the line tangent to the circles. So line tangent to the circles, and compute for the friction angle, yung phi natin, and then yung cohesion natin, kung meron tayong cohesion pag hindi normally consolidated yung soil natin. Kasi pag hindi normally consolidated, meron tayong value ng cohesion dito. So, like this. Ito, this is not a normally consolidated, so meron tayong value ng cohesion dito. So, yung failure envelope natin, yan yung magiging failure envelope natin. So, masosolve din natin yung C prime. And then, yung phi natin andito from the C, ito yung magiging phi prime na natin. Hindi na yung x-axis. Hindi na tayo magsa-start sa x-axis. This is for over consolidated. So, pag hindi normally consolidated, may cohesion tayo. So, using this failure, yung two failure circles natin, we can plot the failure envelope as the line tangent to the circle. So, ito, and compute for the phi and cohesion. So, in this case, yung CD test natin, we will be, this will be an effective stress failure envelope. So, yung phi and C natin will be effective strength parameters as noted by the use of yung prime symbol natin. Pag may prime symbol, that is an effective. So, now let's consider the CU test, or the consolidated undrained test. So in this test, the drainage valve is open while the confining stress is applied and remains open until the soil is consolidated and the pore pressure are dissipated. So we have here the more circles of our CU test. So we have here the, what is that? We have here the sigma 3 for the first specimen. We have here the value of sigma 3. The drainage valve is then closed, creating an undrained condition for the shear phase of the test, and we will measure any excess pore pressure that are generated during shear. So the vertical stress is then increased as the soil fails. So meron tayong sigma 1. So ito yung first specimen natin. Since we are measuring pore pressure during the test, we know that the pore pressure at failure, ito yung pore pressure at failure natin, yung given by this symbol, and knowing that our both total stresses and pore pressure failure, we can compute now the effective stress at failure and plot our effective stress, MC, as shown here. So, itong dash line na ito, yan yung magiging effective stress natin. So, yung una, yan yung undrained soil specimen natin. And then, if we open, if we measure yung pore pressure natin during the test, yan yung pore pressure natin, magkakaroon na tayo ng effective stress. So, this is denoted by this dash line here. So, meron tayong offset doon sa ating total stress doon sa circle by this delta U or yung ating pore pressure. So, in this case, we have an excess pore pressure as the effective stress that is greater than that of the lower than that of the total stress, shifting yung ating more circle to the left. So, ito yung ating dash line. Ito yung ating effective. So, as in the previous test, we can also test the second specimen at higher consolidation stress. So, meron tayong higher consolidation stress. Let's say ito. We can shear this specimen until it fails. Until it fails and determine the total stress of the circle at failure of the specimen. So, at magiging second specimen natin. So, ito magiging delta 1. So, the solid circles, ito, i-offset din natin ito katulad ng ginawa natin dito sa specimen 1 with our delta UD, yung ating pore pressure, para makukuha natin yung effective stress natin. Yan yung ating dash line. So, the solid circles represent the total stresses. So, hindi pa naalis yung pore water natin dito sa stresses natin. Meron pa tayong tubig. So, yung total stresses at failure. And yung dash line naman, it represents the effective stress at failure. Dito, inalista natin yung tubig natin sa ating soil specimen. So, if we consider just the parameters phi, masasolve na natin yung phi natin and yung pag over-consolidated yung soil natin, meron tayong value ng cohesion. So, makukuha nyo din yung C prime for the effective and C cohesion for the total. Yung itong nakikita nyo kasi is normally consolidated na soil. So, wala tayong cohesion. Zero yung cohesion natin. So, therefore, from the CU test with the pore pressure measurement, we can determine the effective stress parameters even though the shear phase is under undrained condition. So, ito yung magiging failure plane natin for our effective. So, tangent dito sa ating effective Mohr circle and yung total stress failure envelope naman natin is yung itong line na ito. Tangent doon sa ating total Mohr circle. So, in solving for the value of P, the cohesion, and the stresses of the Mohr circles, using the Mohr circles of our soil, yung parameters natin, you can use the trigonometric, tawag nito, you can use your trigonometry equations, yung sine, so makaka-create kayo ng triangle dyan, since this is tangent. This is also tangent. And you know that this is pore pressure. Alam nyo na din yung diameter ng ating more circle, which is sigma 1 minus sigma 3, and so on, yung radius. So you can solve for the phi, and then yung cohesion using yung trigonometry equation natin.